Your $1,000 robot vacuum has LiDAR, 3D cameras, and onboard AI. A $5 phone charger on your rug can still shut the whole thing down. How does a machine that expensive get beaten by a rubber wire? You know the sound, that helpless error chime. You walk in expecting clean floors, and instead, your vacuum is stranded in the dark, wheels locked, a power cord strangling its drive system like a trap. This isn't bad luck. It's 3 architectural blind spots, and a loose cable hits all 3 at once. Blind spot 1. The navigation system lies to itself. Indoors, there's no GPS. Robots track position by counting wheel rotations. The moment a cord slips under a tire, traction disappears. One wheel spins in the air, the other still grips the floor. The software thinks it's moving in a straight line, so it keeps pushing forward, pulling more cable into itself until it grinds to a stop. Here's where it gets worse. The cameras can't even see the threat coming. Dark cable, dark hardwood, under 10 pixels on the sensor. Early AI vision was never trained on thin floor debris, so to the robot, that wire looks like empty floor. It drives straight into it. And once contact happens, the hardware finishes the job. Side brushes spin at 200 revolutions per minute, built to pull debris inward, including the cord that just tripped the sensors. Physics does the rest. The wire wraps the axle, jams the roller, and cooks the drive motor. Manufacturers are finally fixing this at the source. Dual anti-tangle rollers replace bristle brushes that used to grab cable. AI models trained specifically on cable geometry now trigger an emergency stop before the wheel ever touches it. So if you're shopping for a new one, skip the suction numbers. 2 specs actually matter: anti-tangle rollers and active cable detection. So next time your vacuum randomly dies on a cable, you'll know exactly why. Subscribe if you want more of these breakdowns, and tell us in the comments what everyday tech we should expose next. Thanks for watching.